Hey guys, this is Coach Lowe, and we are going to talk a little bit about trig today, which is one of my favorite topics to talk about. So this is for trigonometry. Just call me trig for short. Okay, so we're going to talk a little trig today. All right, so before we start that, let's look at what exactly trig is. So the word trigonometry comes from a Greek word that means triangle and measure. So we're looking at measures of triangles, and we're looking at trying to find side lengths and angles using trig ratios. All right, so let's go ahead and draw a triangle. And let's go ahead and label this ABC. So now we have side C, side A, side B. All right, and this is a right triangle. So these are right triangle trig relationships. All right, so we have some ratios that we can look at relating the angles and their sides. So let's begin with angle A. All right, so the sine, and these are the words, this is sine, cosine, and tangent. Those are the three relationships that we're going to look at today. There are abbreviations for these, and I will show you that now. And this does not say sin, so I know you're going to think that, and you're going to say math is the devil and all that good stuff, but it is not. You still pronounce this sine. All right, so the sine of angle A. The relationship of sine with a triangle. The sine of an angle is the opposite side from that angle divided by the hypotenuse. So opposite side from the angle and then divided by the hypotenuse. So check this out. Opposite side from the angle is side A. Adjacent, of course, would be B. And the hypotenuse is going to be C. All right, so the cosine of angle A is the adjacent side divided by the hypotenuse. And that would be, in our case, B over C. And then the tangent of angle A, so there's always an angle measure here. Tangent of angle A is opposite side. And when I say angle measure, it could just be a letter, but that's what that letter represents. That's what the variable represents. Opposite side over the adjacent side. And so opposite side is A, adjacent side is B, so that is A over B in our case. All right. Now, think about this for just a second. Sine is opposite over the hypotenuse, so it looks like this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Just a quick way to remember that. SOHCAHTOA. Cool. All right. It's different when we look from angle B. So check this out. When we're going from angle B, if I want the sine of angle B, see if you can fill these in. Go ahead and pause the video. See if you can find cosine from angle B, sine from angle B, cosine from angle B, and tangent from angle B. Using what we know down here, it's still sine is opposite over the hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Demery, really pause the video and try this out. All right, so see what you think. All right, now that we're back, starting with angle B, we are going opposite over the hypotenuse. So opposite over hypotenuse is B over C. Cosine is adjacent over hypotenuse, A over H. Adjacent over hypotenuse, so that is letter A over C. And tangent is opposite over adjacent. So tangent from angle B is B over A. So make sure you know which angle you're going from and then check out the sides. All right, so let's try one. All right, so we are supposed to find the sine of R, the cosine of R, the tangent of R. So let's start there. And then we're supposed to find the sine of S, the cosine of S, and the tangent of S. And they give us numbers. We're just going to try number one here. They give us numbers for R, S, and T. All right, so let's try this out. All right, so the sine of R, so we'll write our little SOHCAHTOA up here. SOHCAHTOA. So sine is opposite over the hypotenuse. So opposite over hypotenuse, we're starting at angle R. Opposite side is 16. Hypotenuse is 34. We can reduce that, divide top and bottom by 2, and 18/17 is the ratio. All right, cosine of R. And you can just leave that as a fraction, totally fine. Cosine of R. Cosine is adjacent over the hypotenuse. So from angle R, adjacent side means it helps form the angle. So we know this is the hypotenuse. From R, this is adjacent side. This is opposite side. You can label those to start with if you want. So adjacent is 30. Hypotenuse is 34. Again, divide top and bottom by 2, 15/17. All right, tangent of R. Tangent is opposite over adjacent. So from this angle, opposite is 16, adjacent is 30. Again, reduce by dividing by 2, and we get 18/15. So those are the three: sine, cosine, and tangent. All right, now pause the video and you do sine S, sine R, and tangent R. Why did I put tangent R? Sine S, sorry, cosine S, tangent S. There we go. All right, you guys try those three. All right, now that you're back, we're going from this angle. So now this is opposite and this is adjacent. Everything else is the same. So for sine, you should have 30/34 or 15/17. For cosine, you should have 16/34 or 8/17. And for tangent, you should have 30/16 or 15/8. And maybe you notice those are the reciprocals from here. That's because we're going from the other angle, and you're exactly right. All right. All right, so let's talk about our special right triangles that we learned in this previous section and how that relates here. All right, so it says use a special triangle. Yeah, we know this special triangle, don't we? 30/60 right triangle. We are on it. All right, so we know 30/60 right triangle comes from an equilateral triangle. We know the ratios of the sides are A times the square root of 3 and 2A. All right, so we want the sine of 30 degrees. The sine of 30 degrees is the opposite side. Remember, sine is opposite over hypotenuse. Opposite over hypotenuse. So we have A over 2A, or we can reduce the A's 1/2. All right, you can also label these triangles. We can let A be 1. We can label this triangle 1 times the square root of 3, and 2. That works just the same. But we can definitely reduce these and just leave it like that. Either way, it's the sine of 30 degrees is 1/2. All right, let's do the next one. All right, tangent of 45 degrees. We know tangent of 45, or we know the side lengths, the legs are both A, and then I have A times the square root of 2. We can do the same thing here that we talked about on the last one, and we can go 1 times the square root of 2. The ratios will come out the same. All right, so tangent of 45 degrees, so starting from this 45-degree angle, tangent is opposite over adjacent, which would be A over A, which is 1. Notice with the numbers, 1 over 1, which is 1. All right, last one, cosine of 60. So let's run back over here. Cosine of 60 degrees is cosine is adjacent over the hypotenuse. So going from the 60-degree angle, the adjacent side is A, the hypotenuse is 2A. So reducing this, we get 1/2. If you use the numbers, we have 1 over 2, which is 1/2. Awesome. It's good stuff right there, isn't it? Very exciting. I knew you would be excited. All right. Is this the last? Okay, 2 more. All right, so now you're going to need your calculator because we're going to do a little activity here. So we have sides of a triangle, not a special triangle, because we can see this is 36 degrees, and special triangles will have 30, 60, or 45. So not a special triangle, but that's okay. Let's see if we can set up a trig ratio relating these two sides in this angle. So starting from this angle, I have this side and this side. How are those sides related? Well, this is the hypotenuse, and I don't have that side. But from this angle, this side is opposite and this side is adjacent because as I drew this angle marker, it hit this side. So that's my adjacent side. The hypotenuse is also adjacent, but it's already labeled hypotenuse. All right, so what trig thing relates opposite and adjacent? So remember, sine is opposite over the hypotenuse, cosine is adjacent over the hypotenuse, tangent, opposite over adjacent. Ding, 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 tangent. So I have tangent of the angle, now that's 36 degrees, is equal to opposite side, which is x, over 7. All right, I want to solve for x. I want to get x by itself. There's a 7 on the bottom. You can think about this as proportions. I want to multiply by 7 to get rid of it. Or you can just think of this as solving an equation. I'm going to multiply by 7 over 1 to get rid of the 7. Multiply by 7 here as well. All right, on your calculator, you have a tangent button. It says TAN, probably somewhere next to like the division symbol on your calculator. So we want to do tangent of 36 degrees and make sure at the top in the little bitty letters that it says degree. Otherwise, you need to go to mode and change the mode from radian. It may say RAD. You need to change it to degree mode. All right, so tangent of 36 degrees times 7, or you could do 7 times tan, 36. So times a tangent of 36 degrees. And you should get x is 5.085. We'll round that last decimal place, round it 4 decimal places just for now. So really long decimal. Probably in the book they're going to round maybe 1 decimal place, maybe 2. So 5.1 on that. All right. So if they give you an angle measure and sides now, we should be able to set up the ratio and find the missing side length. All right. What if they give you sides and a missing angle? All right, so this gets a little exciting here. Okay, so here's the angle. Here are the sides that I'm given. I'm noticing I'm given the hypotenuse here. So I'm given the hypotenuse, and from this angle, the opposite side. So that is sine, right? Because sine is opposite over hypotenuse. So I have sine x, I don't know that, is equal to 6 over 18. All right, I want to find the value of this angle. All right, here's a cool thing. To get x by itself, we take sine inverse of both sides. So that to the -1 means inverse, sine inverse of both sides. So let me do it. All right, so now it looks like this. X equals sine inverse of 6 over 18. All right, cool thing is you have this button on your calculator also. It's the second key. On mine, it's a green key. So it's second and then sine. So second sine, and it'll put this on your calculator. It'll look exactly like what we wrote. And then it'll have a parenthesis so you can enter the rest. So put in 6 divided by 18 and then hit enter. So 6 divided by 18 and then enter. And you should get about 19.5 degrees. 19.47 is what I got. All right. We will do a few more of these practice problems. If you need to go back and listen to the video, then you can definitely do that. But from here, we can do a lot of things. We can find this other angle measure. We can use Pythagorean theorem to find this missing side length. Now we can write all of our trig ratios for each angle. Lots of stuff we can do. And trust me, we will do some of that when I see you again. All right. I'll see you guys soon. This is Coach Lowe, and I'm out.